Here, we have two instructions, a positive edge detection and a negative edge detection. These instructions detect the transition of logic from false to true for the positive edge and true to false for the negative edge. The detection, however, only lasts a single scan cycle of the CPU, which is usually just a few milliseconds. In this example, we have an input and an output. In online mode, as the CPU executes and determines that the input is not energized, the output result is false. If we energize the input, we see that the output is true. As the CPU continues to execute, the output remains true as long as the input is true. Let's go offline and insert a positive edge instruction here and assign the bit address MOO. After saving and downloading, because we have not yet energized the input, the CPU executes and the output is false. If we energize the input, you can see the positive edge instruction has gone from false to true. So the positive edge will pass the true result to the output, but only for one scan cycle. If the input remains energized, the output will not solve true until the input again transitions from false to true, or a positive transition. Remember that the positive edge is only detected on a transition, so the scan cycle immediately following the energizing of the input is the only positive transition that the CPU saw. In the next lesson, we're going to replace the positive edge with a negative edge and see what happens.